We discussed last time that PNP transistor, for example, here in a normal mode of operation, the emitter base junction is forward biased and base collector junction is reverse biased. Is that clear? We said base emitter junction is forward biased and base collector junction is reverse biased. This is called normal mode of operation, and we say because this is forward bias and this is heavily doped, of course there will be a ends of PO kind of things, e to the power q VB by KT on this side going to NPO. But however, the major interest for us is the hole profile in the base, because the diffusion current in the base is decided by the gradient which holes create in the base region. So we wish to know how the base profile goes, and we'll see that typically this is something like that I may get. Okay, I like to see why we get such kind of profile. But once I get this profile, I'll be able to calculate the dPn by dx at x is equal to 0 and at x is equal to W as well. Why x is equal to W I am interested in? Because the collector current will be decided by the gradient at x is equal to W, and at x is equal to 0 it's the emitter current which will be decided. So at the two boundaries of the base, I'd like to know what's the gradient, and once I get those gradients, q dp by dpn by dx is the current I can get, or current density I can get. So I want to know this profile. Right now assume we are in steady state. What does that mean, Khopkar, steady state? Time dependence is 0. If someone asks you instantaneous value, then is it time independent? No, it is time dependent. At that t is equal to something is called instantaneous value. So at that time don't make d by dt term 0, because you are asking at that instant. Okay, it's called instantaneous value, is essentially time dependent value. Is that clear? We'll calculate that also, because why we are interested in that kind of calculations? For AC signals or for any kind of signal which is varying, you will require to find time dependence. So at that time we'll come back and say, okay, that dp dn by dt is not 0, but what is it? We'll evaluate. Till then, assuming steady state is achieved by biasing and I repeat, VBE is positive. Positive in the sense PN junction is positive. Okay, this word should be clear. It doesn't mean that this is positive. This essentially means this is negative, this is positive, or maybe instead of positive I should say forward biased. Makes it forward biased, and VBC is such that you get reverse bias. So if I write delta Pn by dx, or rather dt, sorry, where Pn is the carrier concentration of holes which are getting injected here. Okay, so dPn by dt is also we may write for the sake of this delta Pn by dt. Why this is equal? Because time dependent of a constant quantity is anyway 0, and this I'll make it 0, and then I write, what is the term I should write? 1 upon q djp by dx minus delta Pn by tau p. This is the continuity equation in which time dependent term is 0. Is that clear? Now if I want to solve this, and then I say Jp is qd minus qdp dpn by dx, can also be written as qdp d of delta Pn by dx, and then I substitute there. Okay, differentiate this, substitute here, and the kind of expression this will lead to together will lead to d square delta Pn by dx square minus delta Pn by Lp is equal to 0. So it's LP square. Okay. dP tau P will be LP square. This we have done in the PN junction. I am just directly writing. Just substitute differential of this here and make it equal to 0. This is the expression. So once I get this profile, I can solve this equation. This is second order, simple equation, linear equation, and therefore solution is very trivial in fact, or very well known. I repeat, there is no non-linearity here. What does that non-linear term should come from? If there is a term which is delta Pn is also function of x and something else, then it will become non-linear. Right now it's only a function of, there is no Pn into x term appearing here. Is that correct? There is no Pn into x term appearing here, so otherwise it will become non-linear, but that's not the case here. So what is the solution of this? Let's take some constant e to the power x by Lp plus C2 e to the power minus x by Lp. This is a second order straightforward equation. If you don't know this, solve it, integrate twice, you get the same thing. So if I know the solution, then what I am interested in? To find C1 and C2. And once I know C1 and C2, of course, to be precise, I must now start writing Pn as a function of x. Pn is everywhere function of x. That's what we are interested in. Profile, is that clear? As the holes enter base emitter junction, they will diffuse towards collector and they will create a gradient there. And that constitutes the current. Current is given by this equation. Is that correct? Simple diffusion equation. What is we are saying here? That right now, I may say, there are other currents also possible. This current, which we may right now neglect. We may say all that emitter current is giving by the whole current. What is this condition is telling? If this value is extremely small, e to the power, and that is the doping in emitter is very, very heavy, the current, diffusion current coming from here, q dn by dx, will be extremely small compared to q dp by dx on this side. So IEP will be smaller, larger than IN. But if you keep that term, there is nothing wrong with it. It will always be numerically smaller and can be neglected in numerical terms. But all that will happen analytically, it will become a little difficult to keep those terms all the time. So right now I am only interested in current which is entering here is IEP, and I say if I know my gradient, then I can calculate the base emitter junction. So now I have to get this equation solved, that is the C1, C2 to be known, I need a boundary condition. There are two boundaries. One is here, one is here. Please remember, this is base emitter junction forward bias. Is that correct? This is base collector junction reverse bias. And these 2 points are very important. At x is equal to 0, the excess carriers delta Pn x at x is equal to 0 is nothing but Pno e to the power q. We have done this, I will not repeat again, minus 1. We know it is any time the bias is applied, e to the power that value it will pump, minus Pno because excess I am looking for. This value I call delta Pe. Is that correct? Rastogi? Delta P. Hold this expression, I say excess carriers at base emitter junction is this delta P. By similar argument, I say at x is equal to W, delta Pn at x is equal to W can be written as Pno e to the power q VBC or VCB, whichever way you write. Please remember this, I may write wrongly sometime VBC. Please in reality place correct signs, because minus means it should appear minus. Okay. Now in the case of reverse bias, what is the VCB value? Negative and very large. At x is equal to W, this is a reverse bias junction. Under reverse bias junction, what is the Carrier concentration at boundaries, they go to 0. They go to 0. So essentially what we are saying, that under reverse bias, if this term is very small, why it should be small? Because it's essentially minus QVCB. Reverse bias is much stronger in normal case compared to base emitter junction. So this term is much smaller, which is essentially equal to minus PNO, but this is excess carriers. So the actual carrier is 0 at boundary. However, not to keep it like this, we say this is delta PC. This is essentially, and can this be, sometimes we will also equate it to, because minus PNO is very, PNO itself is very small, so we say minus PNO is even lower, I mean is small value, can be neglected. So what does that, if I do right, what does this point will go then? This is minus PNO, where it will terminate then? At x is equal to W, if I say at x is equal to W, the net carrier concentration there becomes 0, or excess also is 0 because we say PNO is very small. This is an approximation which will help us to do a lot of good things faster. Okay. But if you don't keep, there is nothing absurd about, keep this delta PC. Now why I am not interested in putting minus PNO or 0 immediately? Because I have told you there are 4 possible modes in which transistor could be operated. This is forward bias, this is reverse bias. This is forward bias, this is reverse bias. Both are reverse bias, both are forward bias. So if I keep delta PC, delta PE as names and then substitute voltages corresponding to forward or reverse, then I am now looking into a transistor which is more generalized form. Is that clear to you? If emitter will become collector and collector will become emitter, so I say it's an inverse mode of operation. This will be collector current, this will be my emitter current. So I want to keep the delta words as it is. Biasing will decide whether it is forward bias values or reverse bias values. Once I know these two equations, two boundary conditions, these are two VCs. I can substitute in this, is that clear? Two unknowns, two VCs. I can always be able to calculate both C1 and C2. Is that clear? What do you do first? Put x is equal to 0. So at delta Pn 0 is essentially C1 plus C2. At x is equal to 0, this is C1 plus C2, so equation A. And if I put delta PNW, it is C1 e to the power W by LP plus C2 e to the power minus W by LP. This is equation 2. Two equations, two unknowns, and these values are delta PE, this is delta PC. Two equations, two unknowns. Is that delta P's are known? Therefore, two equations, two unknowns. Solve A and B simultaneously, or take C1 is equal to this delta P minus C2, substitute here, get the value of C1, resubstitute, get the value of C2. So instead of spending a lot of time, I just will give you, or maybe you can spend time if you wish. So is that boundary conditions clear to you? Please, this is very relevant because this is I am going to use n times. These are boundary conditions. Only boundary condition right now I say I may use later delta PC as 0 for simplicity, but if you keep delta PC as a value, it may happen whatever it has. Okay. So let's solve using this boundary condition and these two equations which we got. I evaluated C1 and C2. मेरा वैल्यू है, आप अपना देख लीजिए. C1 is delta PC minus delta PE e to the power minus W by LP divided by e to the power W by LP minus e to the power minus W by LP. Okay. This is C1. and if I do this, what is C2? Once I know this, delta P minus C1 is C2. So I calculated that and I get delta PE e to the power W by LP minus delta PC divided by the same value W by LP minus e to the power. Please remember C2 is delta PE minus C1. I use this to calculate my C2 value. Okay. Once I get this, can you see some functions in, what is this kind of function should tell? It's a hyperbolic functions I am looking into. So the solution of currents should show me some hyperbolic values of W by LPs. Is that correct? So let's solve that. Substitute back here. This equation can I rub this part? Since I know C1 and C2, I can write delta PNX is delta PE delta PC minus delta PE e to the power minus W by LP divided by e to the power W by LP minus W by LP. This is my C1 e to the power X by LP plus delta PE e to the power W by LP minus delta PC divided by e to the power W by LP minus e to the power minus W by LP e to the power minus X by LP. Is it okay? Just substitute C1, C2 in the solution. What is the purpose of this delta PN? I want to calculate the diffusion current. Is that correct? I want to calculate the diffusion current. Which places I want to calculate? At x is equal to 0. And what will be that current? IEP. What is the current at x is equal to W? ICP. The current entering the collector. Is that correct? So I will be able to say I calculate collector currents and emitter current from the whole profile in the base. Please remember, I keep saying earlier, in MOS transistors, minorities hardly pay, of course they do now, but in most theory which we did, we say minority currents are practically negligible and it's only the majority carrier transport occur, drift transport. Whereas in this case, which current is dominating? The minority carriers current is dominating. Why I keep saying minority? Because if it is the NPN transistors, which will be minority current due to electrons, because electrons from emitter will go to the P base, so we call it minority carriers. Instead of saying electron and hole, we say minority carrier transport dominates the bipolar currents. Is that clear? Whereas in MOSFETs or other FETs, it is the majority carrier transport which dominates. Having said so, what is the current IP, let's say at x is equal to 0 is minus QA. AY, but instead of J I am putting I, QA dP d by dx of delta Pn x at x is equal to 0. Is that correct? And this current is essentially IPE. The current, or IEP I should say, IP is not correct. Emitter current entering the P region, whole current entering the base region. If I differentiate this and then substitute x is equal to 0, because that's what the condition I am looking for. So I first differentiate that d delta Pnx by dx is equal to, this is all constant with x. Is that clear? There is no term x here except this term is coming from here. So which will get, let's call delta Pc minus delta Pe e to the power minus w by Lp divided by e to the power w by Lp minus e to the power minus w by into 1 upon Lp e to the power x by Lp. Is that okay? E to the power only 1 by Lp will come plus, and why it should be plus or minus? It should come minus from this differential, so I put it minus, and the other term is delta Pe e to the power w by Lp minus delta Pc e to the power w by Lp minus w by Lp 1 upon Lp e to the power minus x by Lp. This is the differential of that. Is that clear? Please remember, these are only voltage dependent term and technology or device dependent term. There is no x part in this, so they remain constants. So if I now substitute the two cases of interest, which are the two cases I am interested in, at x is equal to 0 and at x is equal to w. So the second current which I will get it now, same this, but at x is equal to w, and once I get this, I will be able to find both collector current as well as emitter current. Is that correct? So first do emitter current. So IEP, please remember, this is minus, this is plus, but there is a minus sign there. Is that correct? There is a minus. Why this minus has appeared? This is how we define the whole current going across the gradient is, current goes opposite of that. So it's a minus gradient, so therefore it shows the minus sign. Charge is positive but the gradient is negative, so it's showing minus. In electron what happens? Charge is negative, gradient is still negative, so it becomes plus QDN. So please remember, when I go NPN transistor, this current should be written as plus QADN delta N by dx. Is that correct? Plus there. This fact should not be forgotten. Okay. Okay. I did this delta PNX substitutions, but just look at before we actually solve this. This is a constant. This is a constant. Okay. So I may say, instead of right now IEP, I may call this M1 e to the power x by Lp plus M2 e to the power minus x by Lp. M1, M2s are constant, and I am using same as given in the Speakman's book, because if you per se, once a while open that book, you should happen to see same terms. M1, M2 is, this is M2 and this is M1. What does this function tell? This function is decreasing function with x, this function is increasing function at x. If I plot this across this boundary, let's say here, I figure out one term is like this, the other term is like this. This is e to the power x by Lp proportional to this e to the power minus x by Lp, and if I say delta Pc is 0, one can see very clearly this will be only delta Pe dependent. I repeat, what did I say? If delta Pc is taken 0, then the two terms must be such that when I subtract them, this is the value should be same, so that the net current is 0 at x is equal to w. Is that correct? I repeat, this is not current, this delta P I am plotting. I repeat, if delta Pc is 0, then the delta P rise and fall should be at this point, this minus this must be 0, because that the delta Pc is going to be 0. So if I really plot this, add these two terms, I get something like this. Maybe I'll redraw it. I'm going to get something like this. If I don't put it, keep it minus PNO here. Okay. So I say this exponential functions equivalent which I am plotting, they can be approximated by a straight line. Okay. this exponential, if it is the time constant is such that they come closer to the, when this will have occur, when exponential function will look like linear, e to the power some function is 1 plus x, is that correct? So when x is very small, what is x in our case? W by LP. So what does that, I am trying to tell. If the base width is very small compared to the diffusion length, this approximation may be valid. Is that clear? I repeat, e to the power x is 1 plus x minus x squared by 2 plus something. If first term has to be maintained, x term has to be maintained, then linearity can be held only if x is very small or w by LP is very small. So one thing, when I want to create some kind of linearity there, what is the condition I must maintain? That the width of the base must be very small compared to what? Under root d tau. That term, what does that mean? Lifetime should be higher for the minority carriers in the base, so that the diffusion length is longer and therefore and width is smaller. I can linearize my profile. What is the advantage of linearization? D by dx is straight, okay, d by dx is very straight, and that means I can calculate the emitter current and base currents, collector currents by simple linearization. If I don't do this, nothing goes wrong. Keep using those expressions and keep solving. There is absolutely no necessity that I should do it, but in many cases I may prefer this. I am just preempting what I am going to do. First I may do with that, but then I say, okay, I can also use to great extent this linearization further, and I say, okay, if delta PC is 0, I can even get very nice lines here. Then the slope is known to me. What is the slope? Can anyone tell me? This is delta P value. कितना होगा इसका slope? ये W है. Delta P minus 0 by W. Straight line है ना? That becomes extremely simple to solve. Is that correct? So if I do what we call straight line approximation with delta PC 0, the solution of getting I's are and IC's are very simple. But however, what we'll do is, for a while we'll keep these and see what happens if they are not generalized case W. I don't know whether what is the value of W with reference to LP. Then we'll keep all of that, get some hyperbolic functions, and then in hyperbolic function also what can I do? I substitute W by LP less than 1 and I say whether I get this value either way. Is that clear? This is the method. Why I keep showing you both methods? Because many times in the books or in calculations we use this linearization without even knowing. So I just want to tell you why we do sometimes this kind of profile and get relatively good results. Okay. Under what conditions? That the PNOs are very small. Is that clear? And that W is very small, at least order less than the diffusion lengths. If that happens, these approximations are valid. So in real transistor, this is very close to valid. We do maintain that. Okay. Therefore, all said and done, this all calculations were performed for your sake. For this to say that the way I solve an equation, how does it help me? I do solve many things longer and then prove, oh, it does the same job. Okay, but anyway, all said and done, I may just write now final currents. IP is minus QA dP. I substitute this delta PNX term there and I get the following. QA dP by LP, okay, into, please write, see whether I am right, cosec h W by LP minus, into delta P, sorry. What is cosec h means? This lower term by 2 is essentially sin h. 1 upon that is this. Okay, so, IEP, it's not cosec h because this term W by LP will also come there. So it will be cot h, sorry, I am very sorry, W by LP minus delta PC cosec h bracket W by LP. Plus sign has come because of minus and minus is cancelled through the calculations. Now can you think, if this term is 0, if delta PC is 0, and cot h term, what is cot h term? If W by LP is very very small, how much is cot h? Anyone? थोड़ा hyperbolic याद करो, 1 by y होता है, 1 by y. So यदि ये 1 by y यहाँ रखूंगा मैं, तो यहाँ क्या आ जाएगा? QA dP LP by W, ये करंट है. कब? When is this current? When delta PC is 0 and W by LP is much smaller than 1. Why I am writing this? Because I am going to prove that the other case, if I would have started with a straight line, I would have actually got this value anyway. Is that clear? Is it, Gautam, clear? Why I wrote this value? If I say delta PC is 0 and W by LP is much smaller, this is the value which I get. Is that clear? Okay, so this of course right now we don't have to write, we just keep this current. By a similar argument, can you see something common between the two terms of IEP and ICP? Wherever there was X, now it is W, X is equal to 0, there it is W. So can you, without doing much, can you tell me what is the IC current, neglecting this ICN current right now? Whatever is the IC is ICP. Just tell me what could be the, by just observing this. Anyone? QA DP by LP. No. थोड़ा सा मैं आपको बोला ना, देख के बोलो. Cosec h W by LP minus delta PC cot h W by LP. ऐसा क्यों हुआ? क्योंकि मैंने आपको बोला कि बेस कलेक्टर जंक्शन, मैं अभी नहीं बोला कि वो रिवर्स बायस है कि फॉरवर्ड बायस है, तो उल्टा करेंगे तो वो उल्टे हो जाएंगे बस. ओके, इसको बोलते हैं सिमेट्रिक थिंकिंग. जस्ट देखो उसको उल्टा करो. ओके, सो नाउ this is IE, I will call IN is smaller, then I say this is IE and this is IC. So what is the base current then? IE minus IC must be base current. If from this I subtract this, I must get the base current. Is that correct? I must get the base current, which I did. So IB is equal to IE minus IC, and I have done this. QA dP by LP delta PE cot h W by LP minus delta PC cosec h. This is IE minus QADP by LP delta PC or delta PE cosec h W by LP minus delta PC cot h W by LP. Is that okay? Just subtract collector current from emitter current. We have got the two current, just subtract. I can slightly modify this expression by saying at least this. W by LP is, and I have noted down a table, just a minute, somewhere for the cosec functions. Oh, it's here. I mean, nothing so serious. Sec hy is 1 minus y square by 2. Cosec hy is 1 by y minus y by 6. Sorry, y by 6. Tan hy is y minus y cube by 3, and cot hy is y plus y by 3. Cottage, yeah. Sorry, thank you. I said it last time, but made mistake. Okay. If I use this y much smaller than 1, I can get rid of these cottage cosec h terms in terms of W by LP, which I did, and the expression which I get now, which you can verify yourself, IV is equal to QA dP W by 2LP square into delta PE plus delta PC. Just expand sin h, cos h, cot h functions in terms of, and what is the condition? W by LP is much smaller, so term take y smaller and take the approximation from there. Substitute here all 4 terms, collect those terms. अच्छा ये इसको और कुछ कर सकते हैं क्या? कुछ दिख रहा है उसमें तुमको और कुछ दिखने जैसा? इसको थोड़ा और खेल सकते हैं हम गेम. QA क्या होगा? ये कैंसिल हो गए. So well and so good. Half QA W upon tau P into delta PE plus delta PC, and if I say delta PC is very small or 0, this is half QAW into delta PE by tau P. क्या है वो? यदि ये if I say delta PC 0 means क्या बोला मैंने आपको? यदि इसे लीनियराइज कर दूं मैं, तो ये क्या है? क्या है वो? देखो, ये डेल्टा P है, ये W है. Is that correct? Delta P into W by 2 is what? Area under the curve, and if I multiply it by area, actual area, this is charge. Is that correct? This is charge, so whole charge. So this essentially IB is the whole charge divided by tau P. आपको पहले बोला था ना, इसलिए प्रूव किया मैंने कि the whole charge divided by tau P, which is the minority carrier lifetime of holes in the base. Is that clear? So what does that essentially means? If I want alpha and beta to be calculated now in terms of charges, then I can also evaluate IC, IB, I in terms of Q's. Okay. What this model will be called if currents are replaced by charges, what these models are called? Charge control models. Okay. All circuit people want charge control models. Why? Because CV, क्यों देखता है उनको? Okay. So these expressions which I derived for you, if I solve it now I rewrite all the three expressions with delta PC 0. Let's say I want to find collector current, base current, emitter current using condition delta PC is 0. इस condition में following currents can be written. I is QA, ये लिख के रखो भैया, आपको काम में आने वाला है. QA dP by LP delta P. This I may use in calculations when I give you problems. Okay. Today night you will see problems now. I see QA dP by LP delta PE cosec H W by LP and subtraction of the two, which is QADP by LP delta PE tan H W by LP. Can we verify this expression and these expressions are same? W by LP is smaller, so tan H is H, tan H is Y. So if what W by LP, this becomes W square, dP tau P is LP square. So this again becomes same as what currents we got there. Is that correct? Okay. So these equations are the ones which we will use when, what is the condition when I say delta PC 0 is valid condition? VCB is sufficiently large reverse bias and the dopings are such that PNOs are very small compared to the doping in the base other doping in the base region. In those cases, delta PC 0 is a valid statement. If not, ye likha hai na? If not, we have all full expression all the time. But once I know this, I can simplify my expressions immediately. Is that clear? I am trying to give you all this because in solving many times problem, W will be given, taus will be given. So you know how much is W by LP to start with. So you don't have to rewrite every time all terms and figure out that the second terms or fourth terms are so small, they are not even getting subtracted or added. So as much as not doing them. How to leave them? We verified that if that happens, this statements can be as well used here. Is that clear? Please verify this condition that W by LP is smaller than 1 and delta PC is 0, that is VCB is sufficiently minus 5 volt 10 volt. Why minus 5 minus 10 volt? What is the value of VB? Across कितना voltage होता है? Forward bias में कितना maximum voltage मिलता है? At best EG. At best EG. Okay. That is heavy doping. Okay, and by then it will become intrinsic. So essentially delta VB is at best 0.6 to 0.8 volts. Is that correct? VB varies from 0.65 cut-in or 0.6 minimum you can say to 0.8 volts. Whereas VCB can be anything. It can be 1 volt, 2 volt, 5 volt, 10 volt. What is the limitation of that voltage? How much I should apply, if this is my collector which is lightly doped compared to base, how much should be this region will decide how much is the VCB I can apply. Is that point clear? Why? Because depletion layer is increasing along the collector contact. All the depletion will come into collector, little on the base. However, when it punches, there is no collector, and therefore we say breakdown has occurred. Is that correct? What is the breakdown? Which breakdown we are getting? Punch through. Okay, we'll get a punch through here. Is that clear? So larger the collector lengths you keep, lighter you keep, the device will stand larger voltages. So power device के लिए क्या करते हैं? इसको लाइटर बनाते हैं और इसको लेंथ 100 माइक्रोन तक ले जाते हैं, इससे वो 1000 वोल्ट तक न पंच हो. Is that clear how voltage are sustained? Because we increase la. But when I just अभी आपको पीएन जंक्शन पढ़ा है, फिर से पूछता हूँ, इफ आई अप्लाई पॉजिटिव 1000 वोल्ट, VB becomes positive 1000, what will device do? It's a heavy injection case. What did I say? It becomes like a resistor, high injection case. Okay? It does not remain because it will push a hell of carriers across, but still VB will become no more than 1 volt. Is that correct? The rest volt will go IR drops. IR drops. This fact correct? So when I apply across a diode, a AC signal of amplitude of 1000 volts, I may get huge current in the forward bias, unless I put a limiter resistor, that current will be huge then, or it may burn. But if I put a limit, I can stop that current increasing. But in reverse bias, it can stand to 1000 volts or whatever volt I decide. This is how the power device sustains megawatts of power. Is that correct? Megawatts of power. Amps and volts in large numbers. Is that correct? This is how we actually create power device. Why I am keeping power device? Because your earlier course you are doing power last semester. So I thought same device is modified to sustain larger voltages and larger current. Current बढ़ाने के लिए क्या बढ़ाते हैं? Actually we need not have larger. Please remember, in all our calculations, we were never looking for currents. What we were looking for? Current density. If I want larger current, then what should I write? I increase the area. Is that correct? Current density still is not very large. Is that point clear to you? Current densities are not huge, but area is huge. So power device will look this size. Diode looks like this. Okay, that's the difference, because area there is huge in the case of power device. Okay, these are some issues because it's electrical engineering, everything has to be done correctly. The reason why I keep saying you all this, because you must know when you go to the labs, why certain things are big, certain things are small, what is limiting it. Okay, you have done a machines lab by now, or you will know? Okay, next semester. So you remember me when some things they put there. Okay. So let's calculate. If I see, please take it. Alpha is alpha 0 times gamma. What is gamma? It's called what? Emitter efficiency. What does that mean? That the carriers injected from emitter to the base and carrier injected from base to emitter, the ratio of net emitter current to the net injected current is called emitter efficiency. So let's calculate alpha 0, gamma. Oh, this should be called alpha t. This is my symbol. Most books do it. Some write alpha t. ये B भी लिखते. Base transport factor is also written in some books as B. Okay, I use alpha t. So I write gamma in PNP transistor is IEP plus IN. Okay, or one can write 1 upon IN by IEP. अभी मैंने जैसे ये IEP निकाला है, इसका IN कैसे निकालेंगे? Same technique with opposite direction. Is that correct? I repeat. How I calculate IN? IEP इधर निकाला है, IN इधर निकाल सकते हैं. ये निकाला है मैंने, और इसका जो वैल्यूज आता है, maybe I can write for you IN. उससे बताओ क्या होगा, ऊपर देख के बताओ IN कितना होगा. DN delta NE divided by ln cot h W by ln. Is that correct? The opposite side. If I solve this finally, IN and IEP substitute here, I get gamma is equal to, very interesting, 1 upon 1 plus QA KT by Q mu n NPO e to the power QVB by KT divided by QA KT by Q mu p by ln, sorry, by ln by lp PNO e to the power qv by kt. This cancels, kt by q cancels, q cancels, a cancels. So gamma is equal to, yes, coming, 1 plus, finally, mu n by ln npo divided by mu p by lp PNO. वो कॉटेज टर्म भी कैंसिल हो जाएगी या नहीं? एक, अच्छा ये सॉरी, ये टर्म नहीं आएगी, क्यों नहीं आएगी आई एन में? एनीवन? बिकॉज इलेक्ट्रॉन, उसका जो एमीटर का लेंथ कितना है, इन्फिनिट तक जा सकता है. दूसरी बाउंड्री प्लीज, this boundary can go to infinite. Is that correct? I'm sorry, I should have said first. Here the base width is very small, so I got W by LP terms. But in emitter is long enough. So at x is equal to infinity, concentration will go to 0 NPO. Okay. So therefore that cottage term will not appear here. And because I keep seeing tannish term coming here, so I was a little surprised. Okay. From this, if I rewrite this expression once again, finally before I quit, gamma is very interesting. 1 plus W mu n, tan को expand कर दिया मैंने, mu n nd upon ln mu p na to the power minus 1. फाइनल एक्सप्रेशन, इसको एक्सपैंड करो, म्यू एन म्यू पी को ऐसा लिख लो, विच इज डब्ल्यू बाय एल पी. इससे गामा 1 करने को क्या करना चाहिए बुद्धिराज? इफ आई वांट टू मेक गामा वेरी क्लोज टू 1, so what is the theory I should do? This should be minus 1. This should be close to 0, which means Na should be much larger than NDs. Emitter doping must be much larger than base doping. Is that correct? ये छोटा है ना, 1 plus 0 होना चाहिए. This I want to be 0, so that means this denominator should be larger compared to the numerator. Also other condition is W should be smaller than ln, which always will be. Okay, W will be smaller than, base width is always smaller. Doping of emitter is kept very high compared to doping in the base, so that this term becomes close to 0 or small. Gamma tends to 1, and यदि gamma 1 हो गया और इसे भी 1 कर दिया, तो alpha will come closer to 1, beta is alpha 0 by 1 minus alpha 0, so beta will increase, gain of a transistor will increase. So transistor design है, base width कम करो, emitter को heavier dope करो. हाँ? कितना heavier आज एक पूछ रहे था, too much heavier also create the opposite effect some other day. It start reducing gamma further. Okay, then see you tomorrow 11:30.